All right, we're taking a look at this question here in Workplace and Apprenticeship Math 20, and we're taking a look at volumes of pyramids. Now, this is a pyramid. It's just flipped upside down, so don't let it fool you. Don't let it freak you out here. This might be, sort of a shape you would maybe pour a liquid into or something. Picture this as an open top. So we might be interested to know how much this holds. So we're going to find the volume. Now, what I'm noticing first of all is that we have a square bottom, right? And the reason why I know that is because the length and the width are equal. So that's going to be easy to find the area of the bottom because we need to find that. But the other thing I notice is that this slant height from here all the way to the point is 2 feet. So we're going to want to make sure that everything is in the same units. So let's multiply that 2 times 12 to get 24 inches. Okay, so 2 feet is actually 24 inches, and we're going to want inches all the way around. So the volume for a pyramid, if you recall, is the area of the base times the height, and in this case, it would be sort of from the middle of the base to the tip, right? That's the height, of course. It might be like a depth, you might think of it, and then divided by 3, okay? So that's the volume of a pyramid. So the third thing I notice here now is that I'm not given the height of this shape. So I am given the slant height, which is the 24 inches, and I'm just going to draw a little triangle down here to represent a situation. So this point right here is this point right here. And the 24 is the length of what would be the hypotenuse, because this is a 90-degree angle. So I'm going to make that 90. And this side right here is this side on my triangle. Now, again, this is from the center of the base to the edge. So if you just move that over, it's like from the center of the side to the corner, which is half of the whole side length. So half of 9 is 4.5. So that's what we're given. And of course, if I find this right here, this height, that's the height of the entire figure. So we're going to have to do a step here. We have to use Pythagoras' theorem to find out what h is. So I'm going to let the square of one side of this right triangle here, this one of the legs there, square, plus the square of the other leg of the right triangle, which is 8 squared, equal the hypotenuse, which is 24 squared. All right, so I'm going to do h squared is equal to, I'm going to get this over to the other side, right? You have to subtract. So I'm going to do h squared is going to be 24 squared minus 4.5 squared. And we'll do that on our calculator here. You don't have to be able to do that in your head. That's okay. So let's clear that. Okay. So 24 squared minus 4.5 squared is 555.75. 555.75. And remember, that's h squared. So we have to now take the square root of that answer. We have to take the square root of that. And that's going to be 23.57, or let's just say 23.6 inches. All right. So that's very important. Now we have everything we need really to find the volume here. So I'm going to flip over to black here now. So the volume of this pyramid is going to be the area of the base, which we know to be 9 times 9, times the height, 23.6, divided by 3. So that volume, let's see, I'll write 23.6 just like you might write here, times 9 we know is 81, and then I'm going to divide that by 3. 637.2, 637.2. And of course, I want to make sure that I have my units in there, so they're all in inches, right? So we've multiplied, this is inches, inches, and inches, so that's inches cubed, or cubic inches. So 637.2, if you rounded that to 637 inches cubed, that would be great. So that's how you find the volume of a pyramid. And you're going to have to sometimes do a little step in the middle here where you're going to have to find an unknown side. And in this case, it was the height that we didn't have, but we can use Pythagoras to find that. Okay? Good luck.